Okay, so the question is, how many grams of oxygen does a human breathe in one day? So they give you 4 pieces of information, right? They give you 4 pieces of information. So how do we start? Well, we can start by making this big problem small. So they ask how many grams of oxygen does a human breathe in one day? So we can start with the breathing part. We can count how many breaths we take in one day. But that would take too long. So let's try breaths per minute. That we can do. So let's say for me it was 12 breaths per minute. But we want it in days, right? So we do a thing called dimensional analysis. All it is, it's a fancy term for meaning we cancel the units. So here, it's just that I have my initial starting point, which is 12 breaths per minute, and the diagonals, if the diagonal units match, they will cancel. So all you do is you put a conversion, right? So we want the units to match, so it's minute, minute, right? It cancels, and hour, hour, it cancels. But these have to be related. 60 minutes is in 1 hour, so we can do that. And 24 hours is in 1 day, right? So we started with 12 breaths per 1 minute. I said I wanted to get rid of minutes, so I did 60 minutes is in 1 hour. So I got rid of minutes, but that's still not what we're looking for. We're looking for days. So then finally, I did 24 hours in 1 day. So hours and hours cancel, minutes and minutes cancel, and we're left with breaths per day. And that is 1.728 times 10 to the 4th breaths per 1 day. But notice that's not the answer because we want grams of oxygen per day. So now what do? Well, now we just got to breaths per day. So we need a way to convert breaths to grams, and we notice that kilograms. So that's one way we can get there. So how do we do that? So if we want to get to kilograms, we have to convert to m cubed. We do have a conversion, m cubed to 1 liter. Okay, so now we need to find a way to get to liters. Oh, there's the piece that helps us. 1/2 liter of air per breath is what we breathe in. So we can use this 1/2 liter, same as 0.5. 1/2 is 0.5 of air per breath. So we can use that and put it right here. So I said 1.728 times 10 to the 4 breaths in 1 day. That's my initial starting point. And the diagonals, if the diagonal units are the same, they cancel. So the conversion I used was 1 breath per 0.5 liters. That's what the information told us. So the breaths cancel, and you're left with liters per day. And that's what here's your answer. So now we're at liters per day, but we're still not at the answer because they want grams of oxygen. Notice that part. It says grams of oxygen. So what we just found was not oxygen, because here it says 20% of air is oxygen. Like when we breathe, we're breathing in the entire air, not only oxygen. So what we just solved for is air. So we have to keep that in mind. So right now, we just converted to liters, right? So now we can use this conversion to get to this one. So that's what I did. I plugged in here. I plugged in 1 liter, so the diagonals match, so they cancel. 1 liter is equal to 0.001 m cubed, right? Because that's the conversion here. 1 liter equals 0.01 m cubed. So I used that conversion. Next, what I did is I want to cancel out the m cubed because I want to get to kilograms. So to get to that, I need a conversion, and it's 1.29 kilograms over m cubed, right? So that conversion came from here because I needed the m cubed to cancel, and this is the conversion, 1.29 kilograms over 1 m cubed. The one's just invisible. And then here, okay, so after all of that, the units, liters cancel, m cubed cancel. You're left with kilograms over day. So kilogram per day is this. And once again, notice how it's air, not oxygen. So now we're at kilograms, but they asked for grams. So we convert kilograms to grams. So now we're at 1.1 times 10 to the 4th grams of air over 1 day. So that's good. Now we have grams of air per 1 day. But finally, we go back to the question one more time, and we see that they don't want air, they want oxygen. So the final piece of information that will help us is 20% of air is oxygen. So what I'm going to do is just multiply by 20%. So when you multiply by a percentage, you can convert it to a decimal, right, by moving 2 places to the left. So I'm multiplying by 20%, which is the same as multiplying by 0.2, and then you get 2.23 times 10 to the third grams of oxygen per day. And so here I didn't do dimensional analysis because this wasn't a unit. When we multiply by 20%, when we're multiplying by 0.2, it's not a unit. It's just, we're just multiplying a number, right? We're just multiplying a number. So that's why I didn't do dimensional analysis here. So finally, we get this number, grams of oxygen per day. We finally go back to the question, make sure that's what they want, and that is, it's grams of oxygen per 1 day. So this is your answer. And I hope that helped, and thanks for watching.